Good morning. Myself is Hemant Verma. I am assistant professor in Technocrats Group of Institution, Bhopal. In this session, first of all, discuss about the first unit of control system. So, what is the control system? Control system manage commands, direct to regulates, and the behavior of the other devices or system using the control loop. And this is the diagram of open loop system when we applied the input, and this is the control system, and we will find out the output. So a control system is a system which provides the desired response while controlling the output. The following figure show the simple block diagram of control system. So in this diagram, we will take the example of the traffic light control system. So traffic light control system is the open loop system because the density of vehicle, it is not depends on the timer. Okay, so it is called the traffic light system control system. And again, is the washing machine is another example of the open loop system. Next. In open loop control system, output is not feedback to the input. So control action is independent of the desired output. So in this diagram, we will see that we will apply the input on the controller. So with the help of the controller, we will get the actuating signal, and this actuating signal pass from the plant, and we will get the desired output. So the basic difference in open loop system, we will not provide the feedback path to the input. So the control action is independent of the desired output. Again, in the closed loop system, we apply the feedback element. So with the help of feedback element, we will find out the error which create in this closed loop system, and this feedback path is minimize this error with the help of the error detector. So in this diagram, we apply the input and we will get the error signal, and controller minimize this error signal, and we will get the actuating signal, and this actuating signal pass from the plant, and we will get the actual output. So it is the basic difference between the open loop control system and closed loop control system. So in case of the open loop system, the control action is independent of the desired output, but in case of the closed loop system, control action depends on the desired output. In open loop system is not required the feedback path, but in the closed loop system, we require the feedback path. So in the open loop system is also called the non-feedback control system. But in case of the closed loop system, it is called the feedback control system. In the open loop system, it is easy to design, but closed loop system is difficult to design because it is a very complicated circuit because we are using the feedback path. It is economical, but closed loop system are the costlier because we generally use the feedback path. So basic in case of the open loop system, we will get the inaccurate output, but in closed loop system, we will get the accurate output because we are using the feedback path in the closed loop control system. So we will get the accurate output. And generally, the open loop system is highly sensitive, but in case of the closed loop system, it is not highly sensitive. So if system will be the highly sensitive, so due to the some disturbance noise, output will also created the distorted output. For removing this type of problem, we generally use the closed loop control system. So with the help of the closed loop control system, we can minimize the sensitivity of any closed loop system. And first of all, we will find out the block reduction technique. We will find out the block reduction technique in any complicated block diagram. So how can find out the transfer function of overall system with the help of these important points. So generally, we will discuss about the summing point. In the summing point, generally summing point add up to signals, but it is depends on the sign. In this diagram, the summing point, the A is the one signal and B is the another signal, and both the sign is positive, so result will be the add up. Y is equal to A plus B. But in the second case, in the summing point, A is the positive, but B is the negative. So final result Y is equal to A minus B. In the third case, we are using the three inputs. A is the positive, B is the positive, and C is the negative. So overall output will be A plus B minus C. Now, second point, we will discuss about the takeoff point. So takeoff point is represented by the node, When the signal pass from the node, and it will be split into the 2 and 3 more parts. Okay, so in this case, it is also called the takeoff point. Next, if two blocks are in series form, if the two blocks are in the series form, then this block will be multiply to each other. So result will be G1 multiply G2. And second case, the parallel connection. So in the parallel connection, two blocks are in the parallel form. So this block will be add up, but it will be depends on this sign. For the G1, the sign is the positive. For the G2 is the sign of the positive. So add on the summing point, it will be the add up. If suppose that if G1 is the positive and G2 is the negative, then result will be the G1S minus G2S. Now, third point is the feedback connection. So in the feedback connection, the feedback path will flow from output to input. So overall output of this feedback closed loop path system, GS is the forward path divided by 1 plus, because in the feedback sign is the negative. So result will be the opposite, 1 plus GS forward path multiply feedback path. And again, shifting the summing point before a block to after a block. So first of all, in this case, summing point before the block, and we will shift this summing point after the block. When we will shifting this summing point after the block, GS will be multiplied on the XS. And second case, when the shifting the summing point before the block. Suppose that this summing point is the after the block, and we will shifting this summing point before the block, then this block will be the division on this signal, 1 upon GS. And now shifting a takeoff point for a position before a block to a position after a block. In this diagram, suppose this is the takeoff point. So we will shift this takeoff point after the block. When we will shifting the after the block, this takeoff point, GS will be division. 1 upon GS. And now in the second case, this takeoff point after the block, and we want shifting this takeoff point before the block. So this GS will multiply this XS function. And this is the basic rule of block diagram reduction rules. So first of all, we will check the block which are connected in series. If any blocks are connected in series, first of all we will solve of that block. And secondly case, if the block are parallelly, then it will be simplified. And the third case, if the block in the block are any closed loop path, and thirdly we will solve this closed loop path. If there is difficulty with takeoff point, while simplify, shift it towards right. If there is difficulty with summing point, while simplify, shift it towards left. Rule number 6, repeat the above step till you get the simplified form. Single block. The transfer function present in the single block is the transfer function of overall block diagram. And we will consider this block diagram. It is a very complicated block diagram, and we will solve this block diagram. Okay, first of all, we will solve that block which are connected in the series. So in this diagram, G1 and G2 in the series. So according to rule number 1, first of all, we will solve the G1 and G2 because G1 and G2 in the series form. So result will be G1 multiply G2, G1 multiply G2. And second case, G4 and G3. G4 and G3 are in parallel form and sign is the positive. So in this point, G4 and G3 will be add up because both the sign are same. So result will be G3 plus G4. Result will be G3 plus G4. Again, this is the forward path and this is the feedback path. This is the forward path, this is the feedback path. So overall transfer function of this closed loop path, forward path divided by 1 minus, then result will be plus 1 plus forward path multiply feedback path. Now again, this is the takeoff point. Takeoff point, we will shift this takeoff point after the block, then G5 will be the divided on the feedback path. So again, we will see that G3, G4 and G5 in the series form. In the series form. So we will multiply this function G3 plus G4 multiply G5. Again, next case, this is the feedback path and this is the forward path. So we will solve this closed loop path. So result will be G3 plus G4 multiply G5 divided by 1 plus G3 plus G4 multiply G5 multiply H3. And now again this block and this block in the series form, so it will be the multiply. So result will be G1, G2, G5 bracket G3 plus G4 divided by 1 plus G1, G2, H1 bracket close 1 plus G3, G4 multiply G5, H3. And in this block diagram, this is the forward path and this is the feedback path. Again, this is the closed loop path. So result will be the forward path divided by 1 plus, this is the plus sign. So result will be the minus. So 1 plus 1 minus forward path multiply feedback zone path. So it is the overall transfer function output to input. Okay. And now we will discuss about the signal flow graph. So in this signal flow graph, first of all, we will find out the overall transfer function with the help of Mason-Gain formula. So Mason-Gain formula, summation of Pk delta K divided by delta. So first of all, in this signal flow graph, we will find out the all possible case, the signal will flow from the input to output. So in this diagram, we will see that the signal will flow from the input to output. So in this diagram, RS, the signal will flow from 1 to G1, G1 to G2, G2 to G1, and 1 to G3, G3 to G4, and G4 to 1. So is the forward path, it will be the G1, G2, G3, G4. So we will check the another forward path. So we will see that there is no another forward path. So it is only the one forward path. Now we will find out the delta 1. How can find out the delta 1? We will check the all the loop. So first of all, we will find out the all the loop in this signal flow graph. So first of all, how can check the closed loop path? So first of all, we will check the all feedback path. All feedback path. So this is the minus H1 feedback path, minus H2 feedback path, and S3 is the feedback path. So it will be definitely that there will be the three feedback path. So it will be the 3 closed loop path. So in this diagram, G1, G2 and minus H1 is the first closed loop path. So result will be the minus G1, G2 multiply H1. And again, this is the secondly G2, G3 and H3. In the second loop, G2, G3 and H3. And again, this point G3, G4 minus H2, again the third closed loop path. And now we will check this if all the loop are touching this forward path, then delta 1 is equal to 1. So we will check this all closed loop path. We will check all closed loop path. If all closed loop path are touching this forward path, then delta 1 is equal to 1. So there is no P2 or delta 2, no more. And again, we will check the two non-touching loop. If the if in this signal flow graph there are two non-touching loop, then it will be the multiply. So G1, G2 and H1 and G3, G4 and H2 is the two non-touching loop path. So it will be the multiply. So result will be the G1, G2, G3, G4, H1, H2. Now we will find out the delta. Delta is equal to 1 minus sum of all individual loop path gain plus sum of all two non-touching loop path gain minus sum of all three non-touching loop path gain. So overall transfer function summation of P1 delta 1, because it is only the one forward path. So summation P1 delta 1. If two forward path, then result will be the P1 delta 1 plus P2 delta 2. But it is only the one forward path. So result will be the P1 delta 1 divided by delta. So P1 delta 1 result will be the G1, G2 multiply G3 multiply delta 1 value is the 1. So result will be the G1, G2 multiply G3 multiply G4. Again, delta is equal to the this function 1 plus G1, G2 multiply H1 minus G2, G3, H3 plus G3, G4, H2 plus G1, G2, G3, G4, H1, H2. Okay. So it is the overall transfer function of signal flow graph from output to input. So we will discuss about the next example of the signal flow graph. In this signal flow graph, we will find out the all possible case of the forward path. So in this case, from the input to output, the G1 to 1, 1 to G2, and G3 to G4, and G4 to 1 is the first forward path. So result will be G1, G2, G3, and G4. Again, again, secondary part, we will discuss about this secondary part. This is again the forward path from G1 to 1, 1 to 1. So result will be the G1. Okay, this is the secondary forward path. And again this G3 to G4, G3 to G4. So again, this is the G3 to G4 is the again the third forward path. And okay. Thank you very much. This session has been completed. And the second session, we will discuss about the time domain analysis.